Hello, how are you today again? Welcome to my channel. Hit the subscription button to be able to subscribe to my channel and get you posted with videos every time. So welcome to today's lesson. Today we are talking about still on loci, and we have an example of a question there. Given line AB, so we have line AB. So we have line AB. Draw the locus of a point Q such that AQB is greater than or equal to 60 degrees and AQB is less than or equal to 90 degrees. And you're also told to share the region where Q lies. So in the previous videos, I showed you how to construct a constant angle loci, and today we are going to apply the same knowledge to deal with that. Now remember, we have a point A, B, and we have the Q here is the locus. So we don't know where the locus is, but we can be able to create it using the conditions we have there. So because we have two conditions here, there is the locus is such that AQB is greater than or equal to 60 degrees. That's one locus. And there's another locus, which is AQB must be less than or equal to 90 degrees. So in such a question, when you see such a range, you'll have to draw two locus. One is an angle. The angle AQB should be greater than 60, and the other locus will be AQB should be less than or equal to 90 degrees. So let's begin by creating the first locus, where angle AQB is greater than or equal to 60 degrees. So step number one, you're going to construct 60. At A, place your protractor like that. So you place your protractor like that, and then yeah, there you go. So this the line AB falls in your line in the protractor. Then you measure 60 degrees. So 60 degrees is actually there. Then you join the point of 60 degrees to A and project that line a little bit. Then the next thing, we need to construct a perpendicular bisector through A. So because we have the line there, you come to A, you put an arc there. Also move to the other side, you also put an arc there. Once you're done with that, you place your protractor, your compass, to the two arcs, construct a perpendicular down here and another perpendicular bisector there. Come to this other side, you construct a perpendicular bisector there, this side there, and also that side. So now you join through A, you get a perpendicular bisector through A. The other thing you need to do is to construct a perpendicular bisector of line now AB. You already know what to do. Construct a perpendicular bisector, put an arc there. Come to the other side, you put an arc. With the two arcs now as your center, you put an arc on top. You also put an arc down here. Yeah, there. Sorry about my hands is a bit distracting you, but you also come to this other side, put an arc. You come this other side and put an arc. So the two arcs we have drawn here are these two arcs which are there. So you join the two arcs. So you locate the center of the arcs. Then you draw the perpendicular bisector of line AB. So where the two bisectors meet, put your compass on those points. Point your A. So you point your A there. Point your A with the center. Make sure it is exactly at A. You draw an arc like that. Draw an arc there. Actually, now the arc passes through A and B. Now, as you can see, this is now the constant angle loci, which is 60 degrees. Then the next thing we also need now to do, we come back to the same question. That's the first locus. We can call this point, let's say, the first locus. Remember, we can't label it. Just the locus is only Q. We are going to label it later. Now, the second locus you draw, now you come here. A, Q, B should be less than or equal to 90. We'll deal with this inequalities later. For now, let's deal with the angle first. So A, Q, B should be less than 90. Again, come to, now for this case, you come to still A and measure 90 degrees there. Measure 90 degrees. And then you join that line through A, and produce a bisector through A using the same lines you have drawn. So bisect that point there. So you do that. Put an arc. You put an arc. You put an arc. You also put an arc. Actually, the bisectors are still there. You only needed to extend here, but it's good if you just construct for the sake of other angles. So this arc and this arc join to construct a perpendicular bisector through A. So this is a bisector through A. And then the other bisector you need to construct is a bisector of A and B, which is that bisector. You find that they are meeting here. So this is the center of the loci of angle AQB to be 90 degrees. So with that as a center, remember, the 90 degrees was created and through A, and a bisector was created also through A. That was the bisector. Then the bisector of AB was already there. So where the two bisectors meet, they meet there. Make that point to be your center of the circle you draw. Point to A. You draw an arc there. So you draw an arc like that. So that is the locus where the angle AQB is 90 degrees. Now we need to locate now the real locus. We told here AQB is 60 degrees, is greater than 60 degrees, and AQB is also less than. This AQB is greater than 60 degrees. AQB is also less than or equal to 90. So let's first construct. There's something based on from 3 work. There is an angle subtended at the center of a circle is actually 2 times the angle subtended at the circumference of the same circle. So like for this case, we'll notice here, this angle here at the center of the circle is 180. Then before that, before we even go there, the locus there, we can just decide to find the locus. Let's join A to the first locus, which is of 60. Find there, we can join there. We find that this angle here is 60 degrees. Let's go to the other locus, which we have already drawn here. The locus here, if we join from A to that locus, and we also join there to that locus, you find this angle to be 90 degrees. So from this scenario, you notice here, before you even notice, let me take you back to Form 3 work. We all know angle subtended at the center of a circle is actually twice the angle subtended at the circumference. So you can see, like for our case here, our first center, this was our center 1, and this was our center 2. So our center 1, if we join A to our center 1 and join B to our center 2, to center 1 rather, you find that this angle here was is 120 degrees. So remember, this center was we were able to put a compass here so that we construct the arc which subtend at 60 degrees at the circumference. Now if the angle at the circumference is 60, therefore at the center it's going to be 120 degrees. When you go back to the other center was here, which is our angle here is 180 degrees. With this with center 2 as our center, we constructed that arc, and we found out the angle subtended at the circumference is 90, and at the center is 180. So what you notice here is based on Form 3 work, angle subtended at the center is actually twice the angle subtended at the circumference. The other side, angle subtended at the center 1, which is 120, is twice the angle subtended at the circumference, which is 60 degrees. Now based on that, we can now shade our region. here. But before you shade the region, you should know that as you move from the circumference towards the center of a circle, the angles keeps on increasing. We have 60, 90, 120, 180. Moving away from the center, the angles keep on decreasing. So you have 80, 180, 120, 90, 60, so on, so on until the angle becomes 0. Now, let's get back now to our region. Let's shade the region. Let's start by the first locus. AQB should be greater than or equal to 60. So the locus AQB, we know the locus we have created for 60 degrees there. It's there. So we are told that the locus should be greater than or equal to 60. So when you go beyond this arc, the angles keep on decreasing. They are becoming less. But remember, our AQB must be greater than 60. So we need regions downwards. So we shade on top of the 60 degrees there, on top of that arc we have drawn. We have already shaded, we have already located the first part, the first condition. The second condition, AQB is less than or equal to 90 degrees. So the other arc here is this is the other loci. Now we need to shade that point. Remember, from that locus, going downwards, the angle keep on increasing. Going upwards, the angle decreases. Now you're told, or the angles below this arc are less than 90. Angles, the angles below the arc are greater than 90. The angles above this second arc are above it. They are less than 90 degrees. So as you can see, AQB is less than 90 degrees. So from here, this is the point where angle is 90. So above it, the angles become less than. So we need above it, above that arc. So we shade. We don't need the values greater than. So we need values less than. So we find that the region we are going to get, the whole of that, this is the region we are going to get. So my view here is that I hope you will be able to follow up the whole thing. You can try that on your own and then try to follow the steps one by one. I'm not sure if you'll be penalized by leaving the region there unshaded, because you've already showed. They're saying you shade the region, but you've already shaded the unwanted region. So the region which is remaining is actually unshaded, but you can either shade it with a plain, just shade it fully, or you can just leave it like that, just leave it plain, but make sure you indicate there are showing the region. So you shade it there, fully shade it. Fully shade it, and once you're done with that, you can write there the R, or if you don't want to shade it, you shade the other unwanted part, then write the region, write R there indicating the region. So that's all for today. See you next lesson. I hope it has really helped you with your mathematics skills and added your mathematics skills there. Subscribe still to my channel and get more complicated videos that I'll be showing and demonstrating in my channel. See you next lesson. Thank you.